MCT4C, lesson 1.5, part 2. We were just finishing up an example where we used the sine law to find an angle B. We came across a statement that was familiar from earlier trig work, this unit, where it had two solutions. And this is what we want to talk about right now. This idea of when does the two solutions, the second solution, come in when we're solving triangles. And it's a bit of a strange thing. So let's get into that. In cases like the example we just saw, we must be careful when we're finding angles using the sine law. Recall that equations like that we saw have two solutions, one in the first quadrant and one in the second quadrant. That's where the sine is positive using the cast rule. We must be aware that sometimes we want an obtuse angle, even though our calculator gives us the acute angle. The calculator will just about always give us the acute angle, the reference angle. We've been talking about that all unit. This is called the ambiguous case. Ambiguous case. Ambiguous means not clear. So in this question, if we're solving a triangle, it's not clear right away whether the answer we want to get is the acute solution or the obtuse solution. If we think about it a little bit, we should be able to state what solution is required, but at the time it's ambiguous. In our example 1b above, the diagram showed that we were interested in an acute angle, so we didn't need to find the obtuse angle. So again, that statement, that sine B is equal to 0.95, what was it, 76? 76. It's got two solutions according to the cast rule, right? It's got one in the first quadrant, and that was the 73 degrees that we wanted. And that second one was in the second quadrant. That's the obtuse angle. That's the one, the 73 degrees that our calculator gave us. But the second solution, the obtuse solution, I'll call it B2, why not, is an acute, or an obtuse angle rather. But of course, that is an acute angle. So that's why we just stuck with the 73 degrees. Angle B was 73 degrees. It was pretty clear we wanted the acute angle. But anytime we're using the sine law to find angles, we have to worry about this ambiguous case business. All right, so in this one we want to solve the triangle. There's a bunch of stuff given, but a bunch of stuff missing. So let's list the stuff that is missing. Angle M is missing, angle N is missing, and side N is missing. So when we fill these things in, we'll be done solving the triangle. And what do we do? Since today is on the sine law, probably we can use the sine law. And there's the angle side pair that we're going to use. We know angle P and side P, so we can use the sine law. And I'm going to use the sine law to find angle M. Sine M over little m. My unknown goes on the top just because that's convenient. And I substitute in. Cross multiply here. And see, here we go. We got sine M equals one of those statements that has two solutions. I go 123 times the sine of 23 divided by 53, and I get 0.9068 about. Inverse sine of that, and I get about 65 degrees. That looks like an obtuse angle. So this is the case where the calculator gave us the acute angle, the reference angle, and say, but angle M appears to be obtuse. So we're going to use angle M is 180, subtract that. That's 115. See, that's pretty important because now that we know that's 115, that's going to change the entire triangle. That's going to change the value for n. If we use 65, we'd get a different value for n because now I'm going to use angles in a triangle, 180 minus 115 minus 23. That gives me angle N, which is 42 degrees, about. And side N now is the last unknown, but I'm going to use my angle side pair and the sine law again to find side N. Some people may want to skip the step and just substitute into the equation. I think I'd be okay with that as long as everything was nice and organized. Just got to show some work from here though. Cross multiply. Now put that into a calculator. We got 53 times the sine of 42 divided by 53 times the sine of 42 divided by sine of 23. I'm just putting that into my calculator because I don't have it done on my calculations. It's about 90.8, and the units are millimeters. Approximate answers, but now that we've filled in our missing stuff, we've solved the triangle. Remember, solving the triangle means finding all the sides and angles, and we've done it. And this is the idea of the ambiguous case. Let's see what else we got. We've got the angle of elevation from one side of a mountain is 48 degrees to the top, and the trip is 8.3 kilometers. From the other side, the angle of elevation is 62 degrees. How long is the descent down the mountain? Well, let's draw a diagram here. So from the horizontal, angle of elevation to the top of the mountain. So from the horizontal to the top of the mountain, this angle is 48. Draw a diagram here. That's 48. And it says the trip is 8.3 kilometers. From the other side, so from the other side of the mountain, the angle of elevation is 62 degrees. Now, let's finish off our diagram. This isn't going to be exactly accurate diagram, but it doesn't have to be. Just a diagram. And what do we want to find? How long is the descent down the mountain? So that's going up the mountain, I guess, if we're going from left to right, and this is the descent down. Let's call that x. And of course, angle side pair, sine law, no problem. X over the sine of its opposite angle, sides on the top, cross multiply, put this into a calculator. 8.3 times the sine of 48 divided by the sine of 62 is, got it here somewhere, 7.0 about kilometers. So 8.3 kilometers up, 7.0 down, and notice that you do just a quick check. 8.3 is opposite a 60-degree angle, and 7.0, which is a little bit smaller angle, should be a little bit smaller side, so that kind of checks out. The descent is 7.0 kilometers. What's the second question? How much distance would be saved if there was a tunnel through the mountain? So this is the tunnel through the mountain. Obviously, we want to find out how long that tunnel is, right? So if this is D, notice that this side D, we don't have the opposite angle, right? So we're going to have to calculate that first, but that's okay. We've got every angle except for that one, so I just go 180, subtract 48, subtract 62, which is about 70 degrees. So that's 70 degrees. Now I can use the sine law again to find, it's supposed to be angle D there. That wasn't a very good D. Much better. D over the sine of 70 is, I'm going to use the stuff that was given to me. Again, sides on the top here. Cross multiply. Jam that into a calculator. 8.3 times sine of 70 divided by the sine of 62 I've got is about 8.8 kilometers. Now notice that doesn't really answer the question. It didn't say how long is the tunnel. It said how much distance would be saved. Well, the total distance is the 8.3 plus the value that we calculated. So the total up and down the mountain, up and down, is 8.3 plus 7, 15.3 kilometers. But then our savings would be the difference between the total and how much there was for a tunnel. Which is 6.5 kilometers. Okay, that's it for the sine law. Now, the last sort of thing of the unit is, what happens if we don't have the angle side pair? And some of you probably already remember from grade 11 or maybe even grade 10, what happens if we don't have the angle side pair? We don't use the sine law, we use the cosine law, but that is another story.